Hi everyone. Hi again. My name is Răzvan Crainea, and I'm part of the OpenSIPS team for 11 years now. And today I will be showing a few updates that came in the last year, as well as focus on a particular feature that we've been developed and we find quite useful for you. So hopefully you will find useful as well. Probably, and I hope most of you know what OpenSIPS is an open source SIP proxy or server. It's quite flexible. It has more than 100 modules. I think it's 150 so far. And it's highly programmable. Basically, you can do whatever you want with SIP traffic. Craft it as you want, fix it, and so forth. It's highly scalable. You can do up, well, this was, we ran some tests a few years ago on some community hardware, and we could do like 20,000 calls per second and have millions of simultaneous calls. And of millions of simultaneous calls, we can have mainly because we are only handling SIP signaling. So we are not involved in the media path. This is quite important because this is what gives the strength of SIP proxy. We don't handle media, therefore we're not limited by bandwidth. We're only limited usually by memory and CPU, but those are not that, let's say, expensive. OpenSIPS is used in various scenarios and various setups. It can be used as a SBC, a session border control. It can be used as a front end of VoIP core in order to ensure traffic normalization, all sorts of enforce codecs and stuff like that. You can use it as trunking. You can build residential platforms. You can do load balancing using OpenSIPS. So, for example, probably most of you are using FreeSwitch or a farm of FreeSwitch. You can use OpenSIPS either as a session border controller, either as a balancer for your existing FreeSwitch farms. You can do call center queuing, and it can also have all sorts of PBX features. Like virtual PBX, it can also act as a virtual PBX. However, we are not handling media. So if you need a virtual PBX that also has media services, you'll have to use in addition FreeSwitch or something like that that can offer media services such as voicemail and stuff like that. However, for let's say signaling like scenarios, OpenSIPS is perfect as a virtual PBX. As I said, I hope most of you know what OpenSIPS is and what OpenSIPS can do. Today I will be talking about stuff that we've developed in OpenSIPS 3.2, then some new features. First of all, we worked some statistics improvements. We added Prometheus support as well, like built-in Prometheus support. All you have to do is run OpenSIPS, load the module, and you'll have all the statistics that OpenSIPS exposes. We also added some extra statistics series because most of the time you don't really want statistics like instant statistics, but you want to somehow get history of how a particular statistic, for example, concurrent calls per gateway worked. This is now available in OpenSIPS 3.2. We added a Kafka backend that can be used for both publishing and consuming events from Kafka. We added limited diameter support, mainly that can mainly be used by IMS instances, but not necessarily. So basically, the diameter support that we added was a first step towards integrating with IMS environments. We added several cloud deployment facilitations. For example, using tags that can be shared across multiple instances, multiple OpenSIPS instances that run behind the same cloud. We also enhanced our existing clustering support, which is basically used to deploy several instances of OpenSIPs that are synced together over a custom binary replication mechanism that we've been using for a while. And also added some media relay abstractions. And this is what I will be talking to you about. So these are some of the new features that we've added in 3.2. We also have a few improvements. For example, we added some security enhancements. Besides, we were using OpenSSL for our TLS backend. Now we also added WolfSSL. We did that to fix some existing issues with OpenSSL without affecting performance. Of course, you will also be able to use OpenSSL, but due to some internal limitations, we had to decrease the efficiency of the module. That's why we added WolfSSL, which gives us the same flexibility that OpenSSL offered us a few versions back. In terms of security, also enhance some of the modules that we have with SSL support. For example, integrations with Redis databases, with RabbitMQ message queuing, with Postgres databases. We added SSL support for all of this, including for our BIN protocol, which is the protocol that we are using to replicate traffic between several OpenSIPS instances. So instead of having the replication traffic visible to anyone like it was up until now, you can have it encrypted using SSL. We also worked out some digest algorithm for user authentication. So instead of using the almost deprecated MD5 algorithm that was being used up until now, we added support for SHA 256 and 512. And we are now fully compliant with the digest authentication RFC. Another interesting stuff that we worked on was to enhance the script-driven B2B, actually to modify the way you were configuring the B2B, the back-to-back module in OpenSIPS. If any of you have used it, most of you have probably done it using XML. Starting from now, you can do it in the script. This allows a lot of flexibility in terms of manipulating the SIP messages that are being sent on different B2B legs. We also added some enhanced tracing. For example, for Homer, we added some special features that can be used to correlate different B2B sessions better. For example, if you have several legs of the same call, for example, if you get a call from the customer, pass it to a core, and then get back the resulted call, and you want to correlate all these in a single Homer instance, you can easily do that using some script helpers. We also added some new tracing facilities. For example, you can trace directly to syslog or to a file, so that you can later see exactly what or debug what happened with a call. And also added some primitives to run MI routes directly for script. This was actually asked for by a lot of our users, because before this 3.2, you had to do some sort of badly looping or localhost looping to send XML RPC commands over different scripts. We fixed all that and integrated the MI interface directly in the script, so you can now do it directly. So as I said, these are some of the features and improvements that we introduced in the OpenSIPS 3 in the new OpenSIPS 3.2 that was released this year in May. So it's now stable and it's free to use. So go ahead and use it. Today, I will be talking about one of the features that was added, and which is the RTP relay. But first of all, let's see what media relay is. Not sure if all of you know the media relay servers that are available. So RTPProxy, which is managed by the guy David was talking about, by Maxim from CP Software. Media Proxy, which comes from the AG project's team, and RTPEngine, which is provided by the SIPWise. All these are media server relays that can be used in order to bypass or enhance traffic with different media capabilities. As I said, OpenSIPS is not a media server, so it doesn't have media capabilities. So therefore, we are relying on these particular media relay servers to offer different media capabilities. What the media relay is used for, so imagine here we have Alice and Bob that are trying to talk to each other. They use OpenSIPS in order to find each other, in order to know exactly, in order for Alice to know where Bob is and the other way around. And since OpenSIPS is not handling media, it's only handling SIP, you notice that the RTP goes directly between Alice and Bob. What the media relay is used for is in scenarios where Alice and Bob are probably behind NAT. Therefore, even though OpenSIPS helps Alice find Bob, Alice will not be able to talk to Bob due to RTP or due to NATing or firewall constraints. That's where a media relay becomes handy. Why? Because media is publicly open and publicly accessible. Therefore, both Alice and Bob will be able to reach the media relay. And once the media relay talks to both endpoints, it will be able to relay traffic from one to the other. So this is one very, let's say, I would say very useful case where a media relay is very helpful. It might be helpful also in an SBC scenario where you have customers on one side and gateways on the other. You probably don't want the gateways to see the IP of your customer, right? In order to fix that, you set up a media relay, and then it will act as a man in the middle. Therefore, the gateway will only see the IP of the media relay, and Alice will only see the IP of the media relay. Again, this is a very commonly used scenario for media relays. You might also use it for transcoding. For example, if you have Alice on one side and Bob on the other, however, Alice doesn't know the Opus codec, or Bob doesn't know the PCMU codec, you will have to set up a media relay which is able to do transcoding so that Alice and Bob can understand each other. So this is another very commonly used scenario. And what we are also using it for is to be able to do conversion between SRTP and RTP. Mainly due to the WebRTC world evolving so fast, now we have SIP phones in browser. However, in order for a browser to talk to a hard phone, which probably might or might not talk SRTP, we will have to do some sort of conversion or transcoding between the two so that Alice can continue to talk RTP to the media relay. However, the media relay will talk SRTP to Charlie. Probably this is not the best scenario that I could come up with. Probably the best scenario is when you want your browser, which talks SRTP, talk to a gateway, which usually, or a carrier that usually doesn't doesn't support SRTP. That's another very common scenario that we are using a media relay and SRTP to RTP conversion. So as you've seen so far, using a media relay, and probably you are using it as well, is very common. And throughout the years that I've been using it, I've seen different problems that appeared. For example, it's very hard to handle multiple branches. What are multiple branches? Imagine that you have a SIP account that is registered in both on my mobile and on my desk phone. These are two branches, and probably my mobile device has like a very new SIP app, which supports SRTP and all sorts of enhanced features. However, my desk phone doesn't support. When I get a call, I should present SRTP to the mobile phone and plain RTP to my desk phone. Doing this sort of multiple branches handling and management can become quite complicated with the current media relays we are using. Another problem that I noticed is that although even though you do manage to match the right flags with the proper branches and start the sessions, when the call establishes, usually you have to terminate the branches that are not being used. And this is, again, more or less quite complicated and needs to do some complicated management in the script in order to make sure you don't get branch leaking. Even further, I think people get focused so much on matching or establishing the right flags for a media relay that they actually forget to complete the process. And to complete the process means two things. First of all, terminate the media session whenever the call terminates. And I've noticed that it usually takes like days or perhaps weeks in order to figure out the right flags to use for a media relay, that you actually forget you have to also terminate that call when you get a buy. Although it's quite simple to do, you actually forget it has to be done. That's because you don't have any, let's say, any feedback. Whenever the call gets terminated, you simply press the end button and don't worry about it. What happens, however, if you don't terminate the calls, you will actually get calls leaking. You will increase the memory on the media relay side, and of course, you will potentially, due to resource consumptions, you will might get a bad performance, bad quality from the media server. So yeah, this is one of the common problems that I've noticed. Another one is handling reinvites or updates. For example, if you want to put the call on hold, this is again very problematic because sometimes we get a lot of complaints that okay, I start the call, I have media both ways. However, if I put the call on hold and I resume it, it no longer works. Well, that's actually because you are not properly handle reinvites and updates. And it's quite fair because it's not easy to handle them. You have to keep track of who's connecting with who, what kind of RTP is using on each side, what are the flags that are being used for each participant, and so forth and so on. This might become quite complicated in a very complex setup. So that's how we came up with the new RTP Relay module. What this new module aims to do is, first of all, simplify how media relays are being used from the script. So up until now, we had RTPProxy, RTPEngine, media proxy. Each one of them come with different functions. We need to use offer for each invite, we need to use answer for each 200 OK. We need to use RTPProxy delete for a cancel and for a buy. This is if you are going to use RTPProxy. If you are going to use RTPEngines, we have different functions. All of these come with different flavors of flags and so forth. So switching between them or even using them might become very hard. That's why we developed a new module that basically unifies or acts as an abstract layer between the modules that are or the media relay modules that we provide and the script. Basically, the script will exposes 3 different settings. RTP relay is a variable that you can use to specify flags for the caller. RTP relay is the flag peer is the flag that you use to specify flags for the callee. You can do it for several branches, or you can do it differently for several callee. And then all you have to do is call the RTP Relay Engage, which basically takes care of all the common problems that I presented earlier. Right? So its goal was to be as generic as possible and offer a common interface for all the supported backends, and to be as simple as possible, minimize the way you use it from script, because probably if some of you have experience with OpenSIPS script, it's quite prone to error. You might, I don't know, break something, or if you miss, I don't know, if you miss a bracket or something and you restart OpenSIPS, it will no longer start. Therefore, you will lose the entire calls. Or if you, I don't know, just a very small change, even if it's grammar compliant, it might break stuff. So the idea is to minimize as much as possible the script interaction. And instead of keeping track of the flags that are being used for each participant, we want to minimize the interaction by only storing a certain information, and to make it as correct as completely as possible. So as I said, there are 3 different variables or functions that you might use. RTP relay, well, I already talked about them. These are the flags that you can use to tune each of these settings. I will not get into details because I feel that I'm a bit of time. Yeah, this is basically a small snippet that you have to do in order to get this working. So simply set the flags for the caller, set the calls for the callee. In this case, we have a WebSocket destination, and call the RTP Relay Engage function. That's it. That's all you need to do. In terms of implementation, we just added a new module. Each backend will still manages its own nodes. It depends on the transaction and the dialog module in order to provide the proper signaling. So it hooks on these events in order to make sure that it uses the proper flags that we define. However, and it does all the magic from there. Of course, you can still hook up in script in order to modify if you want to do some sort of nasty things on sequential messages, but that's not necessarily used. You don't really need to do that if you don't want to. What I want to show you is due to the fact that we know information about both SIP entities and as well as their RTP settings, we can do a very simple media relay failover. So imagine that you have Alice talking to a gateway, and the whole media goes through a media relay server. If that media relay disappears, basically you will a lack of audio between Alice and the gateway. A failover means that we are able to set up a different media relay server that might be on a different server that might have a different IP and so forth and so on, and reestablish the RTP session using that media. Again, we can do that because we have all the information we need in terms of RTP. We call this technique, which is quite useful, media re-anchoring, and it works like this. So whenever we get an invite from Alice, we send it to media server 1 with media server 1's SDP. When Bob responds, Bob will send its RTP to media server 1. When Bob responds with SDP B, we answer the session on the media server. Therefore, as you can see in this graphic, Alice is talking to MS1 and Bob is talking to MS1. Now MS1 disappears, therefore their RTP streams disappear. What we'll do is send a re-invite to Bob, providing him the SDP from media server 2. We can do that because we can create the session because we store the entire information of Alice's RTP profile. This means that Bob will talk with media server 2. Then Bob sends a 200 OK. We will send a re-invite to Alice, providing the SDP of media server 2. As you can see here, we will end up to Alice talking to media server 2 and Bob talking to media server 2. Again, this without re-establishing the call, without any disruptions. All we need to do is determine when the server is down and renegotiate the media server that is being used. These are quite a few use cases of media re-anchoring. For example, for high availability, when a node crashes, you want to move calls to a different node. You can use it to scale up or down. For example, you want to put some, you add some new nodes and you want to balance all the existing sessions. You can use a simple command, which is RTP Relay Update, which goes through all the ongoing calls and rebalances them on a new media server. You can also just move a particular call ID. You can even switch the RTP media relay engine that is being used, for example, to RTPProxy, to RTPEngine, if you, for example, want to offer some SRTP capabilities and so forth. This is quite a very useful mechanism in order to provide high availability and scaling media relays, and it's part of OpenSIPS 3.2. So go ahead and use it. These are the resources that I use for this presentation. We had a training about this, and we will also take this training on Friday, so make sure you don't miss our training. It's about WebRTC, RTP relaying, media re-anchoring, Grafana and Prometheus, and other useful tips and tricks. Thank you very much for hopefully bearing with me so far. If you have any questions.
Razvan, you've done a brilliant job again. Great content, and you brought it into a landing just about on time, for which I respect you immensely. And I want to, round of applause for Razvan for sure.
Thank you.
Very much so. And Razvan, I do want to apologize for that Razvan LiveView mix-up earlier. I'm sorry about that.
Well, you gave me credits that I don't deserve, so I can't, I can't be upset. Thank you.
Thank you. And LiveView, of course, was part of the program yesterday in the morning, which was great. Okay, now, anybody got questions for, Moshe is straight on there, and he's going to come down to the microphone, like a rat up a drain pipe, as we might say in England. Go ahead, Raz. Go ahead, Moshe.
Hi. Okay, I can't believe I'm actually doing this, but unfortunately, I can't remember the details, but I do have a SIP provider, and I have a platform, and the SIP provider and the platform vendor have different ideas of how to implement SIP. There's a slight mismatch, and every day I lose, I don't know, a dozen calls, let's say, when a reinvite goes astray. Is OpenSIPS sufficiently, and I can't tell you what the problem is because I would have to look it up. Okay, I'd have to look up my search terms to figure out what the problem is. But having said that, is there enough tunability or rewriting available within OpenSIPS to help me solve a problem like this? And I'll stay here while you quiz me and ask me questions I can't answer.
No, I won't do that. But the answer is most of the time yes. Well, if you can be more specific, I won't be more specific either because I can. But most of the time, we are able to tune the traffic. Basically, that's what we are doing. Tune the traffic so that each party is happy with what they get.
Okay, very good. So I'm going to say that back to make sure I understood. So actually, you can tune each side of the traffic, generally speaking, and meet in the middle and translate that traffic.
Yeah.
Most of the time, I'm not going to come and beat you up if you're wrong. I mean, I understand. You can't tell with things. But it really is a question of when you send the re-invite and who gets the re-invite first and what to do when you get the re-invite. But yeah, okay. Thank you very much.
Thank you, Moshe. And that was definitely a qualified yes from Razvan. And of course, just another beauty of open source software is if you can read the code, you can open it up and actually have a look at what's going on as well. Razvan, it's great. I don't see any more questions in the room. I'm just going to check the chat. And okay, there's a question from Dave Horan there. I don't know whether that's Dave Horton or Dave Horan. It says, is there latency in the cutover to MS2?
Well, yes, of course it is. I have to admit it, but usually it's not observed. I mean, it's a matter of a few milliseconds or
just a
something
few
like that. Just as until you figure out it's something wrong with MS1, and you immediately go to MS2. So there is a small gap, but usually it's as fast as you can figure out there's a problem. That's basically the latency.
Great. Okay. Well, those are the questions dealt with. Thank you very much, Razvan. Let's give Razvan one more ClueCon round of applause.
Thank you, David. Thank you, ClueCon.